setting up a Kubernetes cluster of Raspberry Pis and also a private Docker repository. So why are we doing K8s and not K3s? Well, it's because in a production environment, you're more likely to find the K8s and not the light version of K3s. So this is more about learning and testing with an enterprise-grade Kubernetes. Most of the setup is similar to the AMD 64 architecture if you're not using the Raspberry Pi. Just make sure to use AMD 64 and not ARM if you're using an actual server. And you may need to change some of the scripts for the installs to AMD 64. Here I log into my Raspberry Pi master and clone the files through Git. Now I do a full update of the firmware. Now I set the static IP address through my router, but you can use the files to do so. They can be found on GitHub in the description below. Here I set Nano as the default editor and put IP address forwarding on. Next we need to install the prerequisites for Kubernetes. These are the latest versions as of this time, but you can modify the script to use a later version once they get released. Here you're going to be required to type in your password multiple times. Now we update and install our firewall. And these are the ports we want to allow. If you check GitHub, there are additional ports that need to be allowed as well. And make sure that port 22 is open, otherwise you're going to lock yourself out. Next, you need to disable swap. Check GitHub for instructions on what to look for. If you find something similar to the instructions, make sure you comment it out. Next, it's time to install Kubernetes. Just keep following along, it may take some time. Moving forward, Containerd is the default runtime for Kubernetes and not Docker. The way we use Docker is to create applications and push them to a registry. We're going to create a private Docker registry within our Kubernetes cluster. We're then going to pull our Docker images and create Kubernetes pods. Here we restart the system and then log back in. Next, we pull the necessary images and initiate the control plane. Then you'll get detailed instructions on what you can do next. But we're not done yet. We still need to create a load balancer with Nginx, and we want a user interface so we can see what's going on with the cluster. We're going to install a dashboard. Also, installing this will manage security and policy. Next, we wait for our pods to start running by using this command. Now we install Helm, a package manager for Kubernetes. We use this to install our load balancer, Nginx. Then we also install our dashboard. This is the official dashboard of Kubernetes. Check the pods again to make sure that all the pods are running. The Nginx admission create and Nginx admission patch will only run once. When done, they're going to be status completed. When editing this file, go all the way down to cluster IP and change it to node ports. Now we have to apply our configurations. This is the dashboard file which we're going to apply. All these configuration files can be found on GitHub. Run this command and look for ingress Nginx, and look for port 443, the external port, right next to it. In my case, it's 30325. If you're on Windows, go to this directory and open the hosts file. You want to add the IP address and the host name to it. Next, we edit the host file on our Raspberry Pi. Then open up this file and check to make sure this is set. After that, we're going to have to set a bunch of configurations. This includes service accounts for the dashboard. You can just follow along, set custom configurations, and apply them. Here we set permissions for the dashboard resources of the dashboard user. Okay, so here we want to copy this token from the dashboard user that we just created. You want to save this for later. Next, we want to create an SSL certificate. Next, open up a new terminal in your Windows machine so we can copy the SSL certificate over. Then we install the SSL certificate on our machine. Once that's done, make sure to use this port to access the dashboard. Then go to the HTTPS dashboard where you'll see that the certificate is now valid. If you don't have a token, you can generate one through here in your Raspberry Pi. Use this token to access the dashboard. From here, you can view and manage what's going on with your cluster. Now we're going to set up our Docker registry. Here I set the storage to 50 gigabytes. And this file matches 50 gigabytes. You can, however, put as much space as you want. You can also generate a registry HTTP secret by this command. Here we create the SSL certificate for the registry. Again, go to your Windows terminal and then copy the registry certificate over. Then you're going to install it just like the previous one. Now you're going to add the certificate over on your Raspberry Pi. Open up your Windows subsystem for Linux and copy your certificate in there as well. This would be the actual machine where you do your development. When you're done, go back to the Raspberry Pi. Now we need to load the configuration files for the registry. This is where you can paste your registry HTTP secret that you created. Here we set our private registry as an alternative source for pulling container images. After all the configurations are applied, go ahead and restart containerd. Then we're going to check it to see if our pods are all running. All the pods should be status running except the first two, which would be completed. Then if you go to the HTTP address and port, you can see the registry. You can also make sure that the certificate is valid. Here it lists all the repositories except we don't have any at the moment. At this point, we're done with setting up the master node. Next, go to your Windows subsystem for Linux or Linux box and begin the installation of Docker. After we're done installing Docker, we're going to push an image to our registry in Kubernetes. This command will install Docker Engine. Because our Kubernetes is running on Raspberry Pi, which is running ARM architecture, we need a way to specifically build applications for it. Now, if you're running this on an actual server, it's not required, but this will help us build for the Raspberry Pi. Listed here are all the supported architectures and emulators. So here we're going to pull an image, rename it to Hello World, and push it into our registry. We can also create an image from our Docker file. Now, a Docker file is a list of instructions and commands on how to build an image and your application. Now, if you go back to your registry, you should see an update to include your image. Now go back to your Raspberry Pi and we're going to deploy the image application to our Kubernetes. This application basically says hello world every 10 seconds. And here we check if our deployment is ready. As you can see, the hello world deployment is running. Now to configure our first node. Here you're going to be repeating most of the steps you did with the master node. Except now you're not going to install the dashboard or the registry or the load balancer. One of the differences between the master node and node 1 is some of the ports that will be open. Once it restarts, go ahead and SSH back into node 1. Here I'm copying the admin config from the master node. Now go back to the master node. This command on the master node will give you another command which you will use on your node 1. Now switch over to node 1 and paste that command with sudo and it will join the cluster. Then in your master node, use this command to check if it's connected. Also, don't forget this command at the end. So now that we're done with node 1, you want to go to node 2 and node 3 and follow the same series of steps. Once you're done, you can go to the master node and check if all nodes are connected. You can also log into the dashboard and check the same thing. And then also check to make sure all your pods are running. Like and subscribe if this helped you out. Thank you.